been joined by Milkshake, who has decided to come and open the door. Hey, Milkshake, do you come say hi? Marshy's here too. I got so many cats visiting me. Hey, come say hi.
Amazing.
Oh, interesting.
Perfectly timed streamer cats.
Yeah. Milkshake is just looking and leering at me from the corner of the room now. Just like,
Oh,
when you least expect it, I will jump on you and dig my nails into your leg.
oh, that's very cute.
Yeah. Alright, day 12. Let's have a look.
Yes.
Passage pathing. With your submarine subterranean subsystem subsisting suboptimally, the only way you're getting out of this cave anytime soon is by finding a path yourself. Not just a path, the only way to know if you found the best path is to find all of them. Fortunately, the sensors are still mostly working, and so you build a rough map of the remaining caves, which is your puzzle input. And this is an adjacency list. So this is a graph problem. I like graph problems. Marshy. No, Marshy doesn't want to say hi. Okay. This is a list of all the caves, of how all the caves are connected. You start in the cave named Start, and your destination is the cave named End. An entry like B-D means the cave B is connected to cave D. That is, you can move between them. So the above cave system looks roughly like this. Goal is to find the number of distinct paths that start at start, end at end, and don't visit small caves more than once. There are two types of cave: big caves written in uppercase, and small caves written in lowercase. It would be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. Jeez, I can talk. Oh, have you tweeted yet? Saying we're live, by the way. Gosh.
I retweeted your tweet. Hold on. I'll make the tweet
Nice.
happen.
So, all paths you find should visit small caves at most once and can visit big caves any number of times. Given these rules, there are 10 paths through this example cave system. So we can backtrack. We can go start A, C, A, End, but we cannot go start B, D, B, End, because B is a small cave and we would be visiting that twice. Let me just push the door too. Alright. So then there's a larger example, but I think I've got this. It seems not too complicated. How about you, Josh? You're alright to go?
Whoa, I'm doing like three things at the same time.
And my kid is just
Yeah,
outside the door.
it's incredibly cute.
He's meowing
Um,
nativity songs at me.
He's meowing nativity songs, apparently. David had
Amazing.
his nativity at school last week. The parents weren't allowed in, but they recorded it, so we should get the recording like tomorrow, maybe Tuesday, something like that. It'll be really nice to see.
What's nativity?
Nativity is like a Christmas play, like about typically about Mary and Joseph and the birth of Jesus and things like that. Very traditionally religious, but you know.
Cool.
Okay, so this seems
yeah.
like we can essentially start and have a recursive solution, which for every node we visit, we keep track of the small caves we've already visited. Every time we recurse, we check if we're a small node and we're in the visited set. If so, we just return. If we are at end, we're gonna return like 1 or something to say that we found a new path. If we're not at end or old small cave, then we're just going to recurse on all of the adjacent caves.
Big caves, right? No.
No, all adjacent caves.
I see. Yes.
Alright.
Cool.
Let's get going.
Right.
Good luck. I'm gonna
Good luck.
cut Yosh from my stream. There we go. Oh, right. So I think. So first, let's.
Hold on.
We need to put this all in the data structure. I think I'll use we could represent this as a full like graph in memory, but I don't think we need to do that. I think we can just use an unordered multi-map, a map from the name to all of its to all connected caves. Okay, so I'll have an unordered multi-map from strings to strings, which is my cave, and I'm gonna do for each line in TL views get lines of our input. For each line of our input, we're going to split into strings the line on minus, I'll just call this S, and then we're going to do cave dot insert S0 to S1, and then we also need to be able to go back, so we do S1 to S0. Okay, so that should build up our cave. Then we're going to count paths with our cave. So count paths is going to return, I guess, the size t. Count paths, it's going to take our cave, put this in a type def. It's going to take our cave, and it's going to take a std unordered set of strings set, which is our visited small caves, which is going to start off at empty. Then what we're going to do is unordered, and we're also going to need a node. Cave. Oh, well, this isn't a cave, is it? This is a cave system. We need to get our names right, this is important. And, whoops. Fix this just now. Okay, so we're going to take our cave system. We're going to take our cave. We're going to take a set of visited small caves. If our current cave is end, then we're going to return 1 because this is a new path. If the cave is a small cave, small cave firsted string constref is return std all of. Check that all of our characters in our cave are lowercase. Okay, if cave, small cave, if it's small cave and visited small caves dot contains cave, then return 0. Otherwise, we're going to, if this is a small cave, then add it to the visited small caves. Visited small caves dot insert cave. Then we are going to get all of our children from our cave system dot, what is the API for this? I opened this earlier. Equal range, returns range of elements matching a specific key. So we do dot equal range cave, and this gives us begin and end. Then we can loop for each connected cave instead ranges sub range. This just lets us not have to bother about doing the iteration ourselves. For each connected cave, count paths visited small caves. Sorry. Cave system connected cave visited small caves. Anytime we recurse, we copy our visited small caves. Okay, then we just need to sum all of these up. So we could do return std accumulate. Oh yeah, if we do std accumulate, we don't even need to use subrange. We just do accumulate, begin, end, start at 0, auto accumulator, connected cave, need to capture by reference, and we're gonna return accumulator plus counting paths. Okay. See out that, and let's give it a try. Where are we? Day 12? Day 12. How's everyone in chat doing today? Strings, line 8. Yeah, I'll do it. Did I just write strings again? Yep, good at doing that today. Hey Rusk, how's it going? How did you find this puzzle? Jeez, how many times did I write strings instead of string? Jeez. Well, I guess that was a copy-paste job. Did I do it? No, that was the last one. I need to hash include numeric. Line 23, syntax error. Identifier was expected, but got type specifier. Whoops. And line 25, missing. Oh, this shouldn't have a semicolon. Cave undeclared, identifier, line 33. System. And here. Okay. Should hopefully compile now. No, count paths does not take one argument. We need to start at start. Oops. Oops. What's going on here? Oh, is this just a mismatch? Between these types? No. Cannot convert from pair of constant strings to string to constant string. Or am I doing that? Line 25. Um. Oh, I guess iterating over a multi-map gives you a stood pair. So this is pair dot second. Let me double check that. Yeah, pair iterator. So that'll be key to value. Okay. I did not paste our input into the file again. Let's start off with this one. And let's double check that our cave system is correct before we do the rest. Whoops, breakpoint on the wrong line. Okay, cave system. Start to A, start to B, A to C, A to B, A to C, A to B, big A to end. Yeah. Okay, that looks fine to me. Yep. Okay. What answer do we get? 10. 10. Okay. Let's try this slightly larger example. See if we get the right answer again. $19. Okay, well that's wrong. Oh, right, sorry, no, that's right. Okay, alright, maybe we're done. Oops. Yay! I'm pretty pleased with that one. I think the code for this looks pretty nice. You know, we have our set of visited caves. If we're at the end, we return 1, we return 0 if we've already visited this cave. Otherwise, we insert into the visited caves, and then we just accumulate all of the paths. Nice. Alright, let's tell Yosh we're done. Hey Yosh, we're done part 1.
Oh, amazing. We're still on it. We just at the parsing step. We were about to like insert the values into a graph, and we still need to like recurse through. How did you do the algorithm?
I just did it recursively. I had a count paths function, which if I which visits a given cave, and if you're at the end, then I return. My function is called count paths, so it returns the number of paths from a given node, and so if your cave is end, then I return 1 because you found a new path. If it's a small cave and you've already visited, then you return 0. If you're a small cave, then I add you to a set of visited small caves, and then I just loop for all of the adjacent caves and recurse.
I see. And how did you track your caves?
Hash set.
Oh, interesting.
Oh wait. Do you mean how do I track the cave system in general, or how do I track the visited caves?
The cave system in general.
The cave system in general, I used hashed multi-map.
Hashed multi-map. Is that like a built-in C++ thing, or is that like
Yeah,
multiple hash maps?
unordered multi-map. Yeah.
Okay. Oh, never heard of it, but it sounds interesting. We were like about to like use the pet graph crate,
Mm,
which allows you to create a graph. But yeah, if you want to read the second one, we can like listen along,
hmm
and maybe I'll get there today, hopefully.
There's a there's a multi-map crate in for Rust.
Oh,
In fact, there's a couple of them. There's multi-map and there's multi-underscore map.
I don't know what a multi-map is.
It's just a map, but each key can have multiple values. That's it.
Oh, I see.
Because like you could represent the graph by making like a full in-memory representation with like pointers everywhere,
Yeah,
but
yeah, yeah.
because the each node is not storing any data, you don't need to do that. You just need to store the adjacencies.
Oh, I see. You could also use like a hash map where the value is a vec of values,
Sure, yeah,
right?
functionally
Okay,
relevant.
cool. Yeah, I might do that.
Cool. All right, so
Thanks.
part two is after reviewing the available paths, you realize you might have time to visit a single pet cave path twice. Okay. Specifically, big caves can be visited any number of times. A small cave can be visited at most twice, and the remaining small caves. Okay, a single small cave can be visited at most twice, and the remaining small caves can be visited at most once. Interesting. However, the cave's named start and end can only be visited exactly once each. Once you leave the start cave, you may not return to it, and once you reach the end cave, the path must end immediately. Hey, Bluesman, yeah, we've been here since day one. Okay, now the 36 possible paths through the first example are many paths. This sounds more difficult. So how do we change our algorithm for this? I realize you might have time to visit a single small cave. Um,
I might dive back into the first problem
yeah, sure, go ahead.
because I have no idea. I'll see you in a bit.
See you in a bit. Okay, so there's a single small cave that we can visit one additional time on every path. So I guess we can additionally in our paths function we can have an optional std string, which is our what should we call this? This is our already visited once special small cave, which starts off empty. So how are we gonna do this? So if we're a small cave and visited small caves contains this already, or cave is start, because we want to just make sure that we don't visit start twice. Hey, thanks to follow Warcon. Let's stick this on a new line. Okay, so if we're a small cave and we've already been visited and the cave is start, we return 0. But we want to have I can check if visited small caves already contains a duplicate. This is a set. I can't have duplicates. I could change the data structure. Okay. So do we need to right, say we've got that that first example, right? do we need to check all adjacent small cave? Okay. Sorry, I'm not immediately seeing what I need to do here. I need to think about this a bit more. So I guess I just say, we say, if this is empty, then we can use the slot. Okay, so we say, if we're a small cave and so if we're a small cave and visited small caves contains cave, then if either special small cave dot has, oh, you're right, yeah, thanks, this can just be a Boolean. Thanks, Plopson. Visited small cave twice. Okay, so if it's a small cave and this contains cave, then if we have already visited a small cave twice, or we're at the start cave, then we return. Otherwise, if we're a small cave, then let's do this here. So if we have visited a small cave twice already, then return 0. Otherwise, we're going to set visited small cave twice equals true. And we just need to double check that if cave is start, then just return 0. Okay. And then here we pass visited small cave twice. Is that right? We just we keep track of if we visited a small cave twice. If we're a small cave and we've already been visited, if we're start, then we just return. If we've already visited a small cave twice, then we return. Can just put this here. Otherwise, we're going to set visited small cave twice to true. Then if we're a small cave but we haven't been visited, we insert ourselves and then we do everything that we did previously. Let's try it. This feels like it's not going to terminate. I feel like it should be overflowing the stack here. This is a recursive function. I've obviously missed something. Let's try the first example. Debug assertion failed. Oh, whoops, I pasted in the wrong input. Silly me. Okay, let's try this. $36. Okay, that's right. So maybe it's just the. Am I building a debug? Maybe this is just the problem. Maybe it's just a algorithmically complex solution, and I'm doing a recursive version, and I'm not building in release mode, so I get what's going on here? I just want to build in release mode. Okay. Am I using one of my many weird builds of Visual Studio that I have lying around? Maybe let's just run it and see what happens. Day 12. I think this is probably it. It's probably just a complex. What's going on? Just algorithmically complex, and I just need to wait for it to finish or get this set to release. Yeah, I don't know what's going on there. Anyway, let's just run this. Hey, thanks to follow X90. Okay, let's let that run. I don't know why that's happening. It's really annoying. Okay, here we go. Should give me. Delete cmake settings.json. Cmake settings.json is the old format. Cmake presets.json is new one. Oh, there we go. We did it! Yay! Hey, Josh, we're done.
Hey, amazing. That was fast. It took you 25 minutes, just about.
Yep.
Cool. We are still on the first one. Shall I do a live share again? Do you want to join in? Mm-hmm. Okay, cool. I'll get a link set up.
Let's just quickly try this. So my solution for part 2 took like a bunch of seconds to complete, but because I was building in debug mode. I'm just gonna try it in release mode and see how fast it runs.
Nice. I have tweeted the link.
Okay. Oh, my. It's funny. I've been building in debug mode the entire 12 days. This is the first time I've had a solution which has taken enough time that I'm like, is this infinite looping?
Right.
Let's try running this. Yes, my solutions are on GitHub Bluesman. As soon as this runs, I'll show you. Okay, how long is this going to take? Okay, yeah, that was a lot faster. All right, cool. I will go and push this to GitHub. Day 12. I am github.com/tartanllama/AOC-2021. All solutions are here. All right, let's live share with Yosh to help out. Live share. Join session. 1 second.
I feel like there's been There's been exactly one day that I was like done before you were, but all the other days you've been like really helping me. And I appreciate it. Yay. Sai is
Oh,
in the collaboration session. Oh, Sai left twice. Oh, joined twice as well. Okay, interesting.
yeah, this happened a few days ago, didn't it?
It did.
Let me just retry it.
I feel like you rebooted Visual Studio and that helped.
I did reboot Visual Studio and that helped. Let me just try one more time, and
Yes.
then I'll
Well,
reboot.
you've left twice more.
Okay, yeah, I'm just gonna restart Visual Studio.
Hey.
Hey, thanks to the follow, XeCat8. Now, how to make it multi-threaded.
Is that even like possible?
um, yeah,
You
I think
need
you could. Yeah, because each path is independent, right?
Hmm. But you would like need to keep a lock for the visited state, right?
No, because each
Uh,
path has. No, because each path has its own visited state
oh, for the second one?
for the first one as well.
Oh, interesting. Oh, wait, that's right. Yeah. All right, all right. Yeah, you're right. Hey.
Okay, we should be joining.
Cybrand 4 joined the collaboration session.
Do you think memoization would be useful for this? Yeah, maybe there's some kind of dynamic programming style thing you could do for this. Is there, because like my recursive solution, I guess you could calculate, if there are sub paths which are shared among a bunch of solutions. Yeah, you could do some kind of sub path memoization, which might help. In fact, one of my favorite algorithms is Floyd Warshall algorithm, which is an algorithm for finding, given a directed, weighted acyclic graph, finding all the shortest paths between every pair of nodes in the graph. And this,
Oh,
yeah, that's the one I was telling you playing Apex like a couple of weeks ago, Josh.
yeah.
Yeah, but the whole thing is this, like, it's pretty much 5 lines of code. Like, this is all initialization work. This is the entire algorithm. It's like a dynamic programming algorithm. It's really, really cool.
Floyd Warshall algorithm.
Yeah.
So small.
All right. So where are you, Josh?
It's line 19. We just did a parsey thing for our lines and we were inserting it into the hash set, which we have done. So we just started like looping through it. We were like, hey, let's take a look at the start nodes. So that definitely a little bit slower than you were. But yeah, we have a struct called graph where we can insert pairs into and like get for any like given node, we can find all the adjacent nodes.
Okay.
So that's what we're doing here. We're saying graph.get from the start node, look for every adjacent node. And we need to turn this into like a recursive algorithm somehow.
Mm-hmm.
We know that much. So we keep track of our visit. And I wasn't sure where to go from there. That's when you were like, hey, hello. I was like, all right.
What is your node type? Okay. Start and large or
Large.
small? Okay. Right.
Small.
Right. Yeah. Makes sense. All right.
Yes.
So basically, yeah, you're gonna want to. So you once you've done the parsing, you're gonna want to break all the rest out into like a count paths recursive function.
Okay. Uh,
So how I did it was my count paths function takes the graph, it takes the name of the current node you're visiting, and it takes the set of visited small nodes. Yeah, small caves.
Um,
Yeah,
okay.
and I made yeah, you could do that and then pass that. I just made it a default argument on the count paths function for visited. Just made it a default construct hash set.
Oh, interesting.
Yeah, so you can do whatever you like. And then the current node, of course, at the start is going to be the start node.
Let's start and then visited.
So then you check if you're at the end, then you're going to return 1 because you found a new path.
Oh, so you return like numbers. Cool.
Yeah. You're going to return the number of paths that you've found from the given node. So if the current node is end, then you return 1. And if the current node is a small cave and you've already visited, then you're going to return 0 because there are no valid paths from this cave.
Okay, hold on. Let's add a is method. Is small. That we can do dot is small.
Nice. That's very nice.
Yeah, I added that to Rust Analyzer.
Oh, really?
Very happy with that.
Very
Yeah.
cool.
So else if current that is small and oh yeah, we do
And visited dot contains
yes.
node or whatever the Rust syntax is for that.
Oh, it is exactly that.
Is it? Yeah.
Currents. Do you end?
Yeah.
Yes, we do.
Then in that case you return 0 because there are no valid paths. Otherwise you're going to sum up the result of calling well, actually first you need to add your, if you are a small node but you haven't already been visited, you need to add yourself to the visited set.
Visited dot insert current dot clone. I think.
Yeah, and then you're just gonna sum the result of calling count paths on every child node.
Okay. So we can do this into a map, count paths adjacent dot sum, I believe. Oh, this function takes 3 arguments. That is because we want to take graph mutably and you visited as well.
You want to clone visited.
Do I? Oh, I do. Oh, that makes sense. Yeah, I see why.
All of visited, every path has its own set of visited nodes, so you want to clone it every time.
Yeah, we don't need to mute. Do we need to mute that graph? No, we don't. So we just pass graph like that. Expected end graph. Okay, end graph, and then adjacent found. Dot get current dot map. Oh, I see why. That's fun. Dot get current dot unwrap. Dot intuitor dot map. Expected type node found. What are we getting? Found and node. Not clone. Sure. All right. Can borrow visit as mutable? Does this need to be mute?
Yeah, because you're inserting into it.
Now that does not need to be mutable. Okay. And then this should be our count, right?
Yep.
Yes. Great. Okay, running tests. Building 0 out of 1. Day 12 has overflowed the stack.
Oh, phenomenal. Oh, good idea,
I love that.
Blobson.
Hmm?
Blobson saying another way to avoid re-entering. So in part 2, you can potentially re-enter the start node, and Blobson's
All
suggesting
right.
just don't add any return edges to start, which is a nice little optimization, but make some of the code a bit nicer as well for my solution. So you overflowed your stack.
Yes.
I did not overflow my stack. Is yours? What's your
Yes.
recursive call?
Let's see if release mode does anything.
Yeah, try release mode.
What? Wait, day 9. Hold on. No, this straight like overflows it.
Okay. Is that just using the test input? Because that
Yeah.
shouldn't be going down very far at all. That probably points to some algorithmic error rather than an actual stack
Yep.
overflow on general
Yes.
input. Like they should only go like 5 calls deep or something. You should not be overflowing your stack.
Yeah, 100%. Maybe what
Can
we
you
can
dump
do
out
is we can.
the? Hey,
Yeah.
have you double checked that the parse is correct?
Yeah, I checked the input. Like we made it past that. That looked good.
Okay.
I feel like we should debug here the current node because I feel like we might be stuck on the current node over and over and over. Or some node will like just keep on printing. Okay, let's take a look. Start large, start large, start large, start large. And we keep
Oh, okay,
printing
right. Yeah,
large.
you so uh that this is because you did it slightly differently from me. Um my algorithm gets start added to the yeah, you're revisiting start.
I see.
Your code looks very
Oh,
similar to mine, but it's just because you handle start and end in a special way because of your parse. Yeah, so one thing you could do is just like Blopson in my stream suggests, you could just not add back edges to start in your parse.
oh, I see. I see. I see.
Oh wait,
Could I not just add
you
it to the set of visited?
you don't add back edges in the first place.
I
you need to
do.
add back edges.
No, I do. I
Do
do.
you?
Yeah. If we look line 59, you can see it creates a two-way like uh
Ah, okay,
edge.
right,
Yeah. But if we add start and end to the visit set,
Um,
or at least start,
you could do that. Yeah.
visited dot insert node start. Is that true?
No, that still won't back out because visited is not small.
Oh, I see. Else if current is small, visit contains. Can I do like current is start or something? Special case that. Or you're simply saying don't act the back edges
Yeah, I mean,
for start.
it's
Yeah.
equivalent. You can do whichever you like.
I'll just do that because people suggest it, and I feel a little bit out of my depth. Okay, so insert. Yes.
Okay, yes, we're doing advent of code. This is a graph problem. Basically, you have a list of nodes which create a graph like this, and you have to calculate all of the valid paths from start to end. You can revisit any node which is capitalized, but you cannot revisit any node which is lowercase. So I've got my solution working, so I'm just helping Yosh with theirs.
Yes. Hey, naughty cat. What's up?
Aw, kitty. Alright, so
Oh,
so you're just gonna do not adding
yeah.
edges
No,
to
no.
start.
Ooh. Kitty almost swiped the cup off the table just by plopping down and being like, "Hello, I'm lounging." Yeah. Let's see how we do that.
Just when you're adding edges,
Yeah.
I'm not sure exactly how you represent your graph, but when you're adding from something else to start, then you don't add that entry.
I see. Because we have a if left is start, then we don't add the back edge, but that doesn't seem to be working on line 63. I just added that like a second ago. I ran the test.
Isn't it?
Is it the other way around?
Isn't it the other way around? Yeah, you want if right is start, because
Uh,
you're not doing from start to something else. You're doing from something else to start.
I see. These graph things like always like twist me up like slightly. No, we're still like looping and overflowing. Oh wait. If not right, I start. Let's see. Do I need to like block out the other one? Is that it? Okay, I'm just very confused.
Right. So how is your graph represented? You've got
A hash map of key is a node and value is a vec of nodes.
okay. So when you add, so the way that the list of nodes is given, start could be on the left or the right of the hyphen. It's just whether, or maybe it's always at the left. Oh no, it can be the right as well. Start can be at the left or the right. You just need to make sure that you never insert start into the node list of your graph.
Yes, that makes sense.
So when you do what you do like a values.push, you just need to make sure that you never values.push start.
Oh, right. Is that it? Hold on. Run test. And we're doing something similar for end, it seems, where we like jump to end and then like jump back. So there's
No,
something in our logic.
As soon as you get to end, you should return 1. So what did I think of day 5 for Advent of Code, the hydrothermal events? Was that the... I'm trying to remember which one that was. Day 5 was... I'm trying to remember how I solved this one. Day 5. I counted intersections.
Oh, hey, our test passed.
Oh, your test passed, nice.
Yeah. Okay,
Yeah, I think for day 5 was fine. I think I just kept a map of all of the valid all of the points which are seen, and then returned if there was if it was greater than 1. Like you could do a scanline algorithm for it, and I thought about doing that, but I've implemented scanline algorithms before, and they tend to get kind of hairy, especially when you have to deal with like vertical lines and things like that. So have you got part one, do you think?
Yeah. Yeah, I just passed it. It worked.
Part two is a pretty
So
small change from part one, so
cool. How do you do part two? Just
part
as a
two, I just I think it's the follow relic fades. For part two, I had one additional parameter to my count paths function, which was whether you have visited a any small cave twice. So for anyone who's just joined,
oh, I see.
uh, the difference with part two is that part two you're allowed to visit exactly one small cave twice. Otherwise, you can only visit them once. So yeah, I had a boolean argument to the count paths function, which said whether we have visited a small cave twice. Yeah, and so then the difference is, so you, if you're at the end, yeah, you return one. Otherwise, if you're small and you have already been visited, so now there's two possibilities here. There's the case where you've already visited a small cave twice, in which case you return 0, or there's the case where you have not visited a small cave twice, in which case you set twice to true, and then you continue with the rest of the recursion.
So the first step is to match. Right. Current is small. No. Uh ah. I know what you mean. I know what we need to do. But then there's like this link in my brain missing of like, how do I express that?
So
What do I
you can do
say?
something like, so if you're
Oh, right.
small, you've already been visited, and you've already visited something twice, then you, well, or actually you could.
So we need
I think
to
what I did was
miss it.
I made this would have to be mutable, and then you in here you check if if you've already visited something twice, then you return.
Yes.
Otherwise, you set twice equals true, and then in here you make sure you pass twice,
Yes.
and that's it. I think.
What line 50 we still need to do something. Return we recurse, don't we?
You just I
Or do we
would
do the
we
fallback case?
get rid of the else. Just
Yeah.
yeah,
Fallback.
make it
Fall through.
fall through the if.
Yes. Type bool cannot be dereferenced. Well, that's on me. Count paths. This function takes 3 arguments, but 4 were provided.
You need to, where you call count paths, you pass false.
No, count paths 2.
Yeah.
I see. Function never used. Okay. So we will copy and paste this into parse 2. Count paths 2, and then false. Let's see if we're correctly mutating the input. All right. So the first one has 36. Oh,
Yep.
we need to copy this over.
36 the first one, then 103, then 3,509.
3,509. Cool. Testing. Left 10, right? Oh, I see why. Hey, wrong function. Okay, and again. Okay,
Passed.
that passed. Instant.
Nice.
Huh. We didn't even like, wait, did that run like in release mode? No, we didn't. Cool. Okay, so that optimized pretty well. Nice. Let's run the full example. Where's our cargo run? Here we go. Day 12, 4, 6, 9. Ooh, okay. So test inputs are fine, but the output two took a sec. All right. Where is our thing? There. Submit. Yay, and our gold star
Yay, we did it.
in 60 minutes, almost exactly. Thanks so much for your help.
No problem. All right, thanks everyone in chat for joining. We'll see you tomorrow.
Yes. Have
for
a
day 13. Unlucky day.
day 13. I'm sure we'll be fine.
Yeah. All
Have
right.
a good weekend, everyone.